In this video, we will review the proper steps for installation of a Warner Electric heavy-duty or spline drive electrically released brake. Vertical mounting installations of electrically released brakes should be reviewed by Warner Electric Applications Engineering prior to use. Please observe proper lockout and tagout procedures for safety's sake. Please note, for this installation you will need to power the brake independent of other machine functions. Before starting, let's review the requirements for installing an electrically released type brake. You will need a flathead screwdriver and Allen wrenches to install wires and fasteners. You'll need a set of steel shims 1/16 inch thick and at least 2 inches in length, a torque wrench with capability to match the rating of the brake you're installing. The mounting surface for the brake magnet must be a non-magnetic surface at least 1/2 inch thick. Finally, you will need an adjustable output power supply. Before we start with the actual step-by-step installation, let's make sure we're clear on the nature of the Warner Electric electrically released brake. Electrically released brakes will release, that is, disengage, when power is applied. When power is removed, the brake will engage. The magnet assembly of an electrically released brake includes a set of permanent magnets in addition to the standard coil. These permanent magnets provide the magnetism that causes the armature to engage against the brake magnet. To release or disengage the brake, DC power is applied. The electromagnetism created in the coil creates a magnetic field that offsets the magnetism from the permanent magnets. As we approach mounting the unit, you'll want to keep the armature and the magnet separate from each other. Do not place the armature near the magnet until you are ready to mount them. If you mistakenly get the armature and magnet clamped together, apply power to them to disengage them. Do not pry them apart. This will only bend the armature out of flatness, causing the unit to fail. Just to drive the point home, take the magnet and a piece of shim stock or a key. When you place the shim next to the magnet, you'll see that it clamps hard and tight to the face of the magnet. On a size 825 like we're assembling, if your fingers are between the magnet and armature, they will be pinched. In a size 1225, you may do permanent damage. We start installation by mounting the magnet to a plate that is non-magnetic material. This mounting needs to be square and concentric to the shaft. This non-magnetic requirement is noted in both the catalog and the installation manual. If the mounting surface is iron or steel, it will provide an alternative flux path for the magnetism and the unit will perform very poorly. The key to getting the auto gap set correctly in a spline drive or heavy-duty unit is the insertion of the splined hub from the correct side. On the hub, you can see that there is a snap ring groove towards one end of the unit. That is critical. Lay out the armature so that it is friction face up. Orient the hub so the end with the retainer ring groove will go in first. This is an interference fit and it will be stiff going through. Push the hub through far enough that the snap ring groove is accessible on the back of the unit. The reason this is critical is that this serves to orient the wave spring, which is the release spring in a spline drive unit. Pushing the hub in from the other side may distort the ring and it will not work correctly. Now that the hub is in, turn the armature over and add the retainer ring into the groove in the hub. Now slide the armature back against the retainer ring. At this point, you're ready to assemble the bushing into the hub. It will enter through the retainer ring side. For now, do not fully tighten the bolts for the bushing. So far, we have the magnet mounted to our non-magnetic surface and the armature and bushing assembled, but not yet on the shaft. We are ready to assemble the armature to the shaft. As noted earlier, with no power on, the permanent magnets will try to clamp the armature against the magnet. To ease assembly, we're going to use 3 1/16 inch thick steel shims to create a gap. Being careful of your fingers, slide the armature and bushing assembly onto the shaft and against the magnet. To continue, we will need to power the unit. Common options for a 90 volt unit will be the MCS 103-1 or the CBC 300. Both are adjustable output controls. While both are rated as 90 volt controls, each can output to slightly over 100 volts DC at their maximum. If you're assembling an ER1225, the MCS 805 is the power supply required. Warner Electric electrically released permanent magnet brakes are polarity sensitive. Make sure you are wired to the terminals properly. You will need to power the control and the brake, but ensure that other machine functions are safely off or disabled. Apply voltage to the magnet. This may allow you to easily remove the 3 shims. If not, adjust the voltage up or down until the shims slide out freely. With the shims removed but power still on, slide the armature against the magnet. Then finish tightening the bushing. As you do so, an air gap of about 1/16 of an inch will be created. Now remove power to the magnet and the brake will engage. The next step is to adjust the release voltage properly. Start with the control turned to 0 and slowly turn up the power until the magnet releases. We release at 8.5 on the dial, around 80 to 85 volts. Continue to increase the voltage until the armature re-engages. Note the voltage at that point. The 2 magnetic fields are no longer in balance, so the unit is engaging. In some instances, the control may output greater than 90 volts. That is normal. In some cases, you may get the control to full power and the unit will not yet re-engage. That's okay. Simply slide the armature against the magnet and it will likely clamp up. Now, starting from the full power position, slowly turn the control power down until the unit releases again. This may be at a value other than the point where it initially released. That's normal. Note this value. We now want to set the control for the midpoint of the second and third position. By putting the release set point midway between the 2 values, power can float somewhat and the brake will still release cleanly. Now, a quick review. We've ensured we are properly mounted to a non-magnetic surface. The armature was assembled with proper air gap set. We adjusted the set point so that it is in the middle of the engage and release range. At this point, your electrically released brake will engage when power is removed and release cleanly when power is applied. Electrically released brakes are factory burnished to ensure the unit will achieve rated torque. However, during handling and installation, static torque may have been affected. Therefore, reburnishing on site is recommended. Burnishing is achieved by cycling the brake in the application. First, ensure that the system can operate safely. During burnishing, expect that the system will cycle 25 to 50 times. The brake can cycle at 5-second intervals, but your cycle rate may be dictated by the mechanics of your specific machine. At this point, it will be prudent to confirm safe machine operation in the event that the brake does not achieve full torque during initial cycles. To complete the burnishing process, you will need a torque wrench that can achieve up to 125 foot-pounds of torque for a size 825 and up to 400 foot-pounds of torque for a size 1225. Burnishing will encompass bringing the machine to normal speed and then engaging the brake. You will repeat this process at least 25 times. It is permissible to run your machine empty if that does not have a significant impact on the inertia stopped by the brake. After completing at least 25 cycles, apply a torque wrench to the output of the engaged brake. You should measure at least 125 foot-pounds for a size 825 and 400 foot-pounds for a size 1225. If you've achieved the torque target, then your brake is achieving rated torque and no further action is needed. If after 25 cycles your brake is not achieving the target torque levels, repeat the process an additional 25 times. If the unit is still not working properly after 50 cycles, contact us at Warner Electric Technical Support. If you continue to struggle with the installation or adjustment process, please contact us at Tech Support.